Hey everybody, this video is the third part of chapter 2.3. Let's see, where did I leave off last time? I think I left off right here on problems 45 through 46. Use synthetic division to find each function value. And so here you just do synthetic division with each of these numbers, and the remainder is the value you would get if you were to plug these numbers into the function. All right, so now I'm going to move on to the last, hopefully the last part. Problem set 49 through 56, use synthetic division to show that x is a zero of the third degree polynomial equation, and use the result to factor the polynomial completely. List all real zeros of the function. Okay, so I'll start by doing problem 50. So we have x cubed minus 28x minus 48 equals 0. And we're given that x equals 4. So that means that x equals negative 4. So the first thing we're supposed to do is we're supposed to show that this is in fact a 0 of this polynomial. Now one way I could do that is to plug negative 4 in for x, and if I do, it should come out to be 0. So this first time I'm just going to do that just to show you what they mean. So I'm just going to replace x with negative 4 here. So this is going to be, let me see if I can get rid of that shadow there. Okay, it's better. So parentheses, negative 4 raised to the third power minus 28 times negative 4 minus 48. And it should give me 0, and it does. So, but it says use synthetic division to show that it's a 0, which means when I do synthetic division with negative 4, so when I do negative 4 in the box, and then we set up our numbers using our coefficients. So the coefficient of x cubed is 1. There isn't an x squared, so I need a 0 for that. The next term down would be negative 28, and then finally negative 48. All right, so bring the 1 down. Negative 4 times 1 is negative 4. Add, you get negative 4. Multiply again, negative 4 times negative 4 is positive 16. Add, and you get what, negative 12? Negative 4 times negative 12 is positive 48. Add, and you get 0. All right, so this shows me that negative 4 is in fact a 0, since I got a 0 remainder. All right, so I've done the first part. Use synthetic division to show that x is a 0 of the third degree polynomial equation. The next part says, and use the result to factor the polynomial completely and list all real zeros of the function. All right, so we know that since I divided by this, since negative 4 is a 0 of the polynomial, that tells me that x plus 4 is one of the factors, right? Because we're going to factor the polynomial. So I found one of the factors already, x plus 4. And I know that because negative 4 is a 0 of the polynomial. Okay. So I can take the resulting, the quotient here, which is x squared minus 4x minus 12, and factor that to find the other two factors. And I believe that factors to, let's see, what, negative, Negative 6, positive 2. Right? So x, because negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. So those are the other two factors. So now I've got the complete factorization. I'll just bring this down with these. And this one, x plus 4. Now I've completely factored this polynomial, right? Sorry, this polynomial here. That's it. So let's try another one. Oh, I haven't finished. Factor completely, and then it says list all real zeros. So so these are the three factors. So the three zeros are x equals 6 because of that, x equals negative 2 because of that, and x equals negative 4 because of that. Okay, now I'm done. All right, let's try one with a fraction here. So 52. So 48x cubed minus 80x squared plus 41x minus 6 equals 0. And x equals 2/3 is one of the zeros. All right, so I'll do synthetic division to show it's a 0. 48, negative 80, 41, negative 6. Bring down the 48. All right, so here's a quick way to multiply a fraction to a number. 2/3 of 48. The quickest way is to take 48, divide by 3, and then if you're doing it without a calculator, I mean. So 48 divided by 3, I believe, is 16. 16 times 2 is 32. So let me show you how I did that again. I started with 48. You divide by the denominator, multiply by the numerator. 48 divided by 3 is 16. 16 times 2 is 32. On your calculator, you would just do 48 times 2 over 3, and that gives you 32. All right. So I'm going to add these. That's going to be 48, I believe, right? Because 30 away from would be negative. It would be 50, so 2 more would be 48. So when I multiply this to this, I'm going to get negative 32 this time. All right, and now the difference between these looks to be 9. So 9 divided by 3 is 3, times 2 is 6. Add, you get 0. All right, everything's good. I was supposed to get 0, I got it, so I'm pretty confident that these are the correct coefficients. So I've shown that 2/3 is in fact a 0. All right, now I've got this other factor, this quadratic factor here, that can be factored itself. I'm not sure what it can be factored to. I think all these are divisible by 3, and this is always the case when you're dealing with a, let's set that equal to 0 for a minute. All right, so whenever you multiply by these fractions, you end up with coefficients that are multiples of whatever the denominator is. So we know that we can divide 48 by 3, right? So since these are all divisible by 3, I can make my life a little easier by just dividing everything here by 3. And since it's equal to 0, which is what I'm going to want to do anyway, because I'm asked to find the zeros, then you divide everything by 3, and this gives you 16x squared minus 16x plus 3 equals 0. All right. So let's see if I can figure out how to factor this. Now, one way we talked about factoring was to multiply the first term to the last term, which is 48. And then I'm going to break that down into two numbers that multiply to 48 but add up to negative 16. And two numbers that come to mind that multiply to 48 are 12 and 4. And 12 and 4 do in fact add up to 16, but I want them to add to negative 16. So I think they're both going to have to be negative. Now they add to negative 16, but they still multiply to positive. They still multiply to positive 48. So what I'm going to do is I'm going to replace that middle negative 16 with these two. So that's going to be 16x squared minus 12x minus 4x plus 3. So all I've done is I replace that minus 16x with these two. All right, and the next step in this trick for factoring is you group them in pairs. So I'm going to have 16x squared minus 12x. Be very careful here. So if you put minus out here, because that's a minus, that's going to change the sign of both of these. So that's going to be positive 4x there, and that's going to be a minus 3. Okay, and then we can see that I can factor out what, a 4x here. So that leaves me with 4x minus 3 here, because 4x times 4x is 16x squared, and 4x times minus 3 is minus 12x. Minus, I can't factor anything out of here except a 1, so that's what I'll do. Factor out a 1, leaving me with 4x minus 3. Notice these two terms are the same, which they need to be. If they don't come out to be the same, then there's a problem. All right, so that means I can factor out from both of these terms here and here. I can factor out 4x minus 3, which leaves me with 4x, take away 1. Okay, so now I've got all the factors, right? One factor I don't, I guess since x equals 2/3 is a 0, that means x minus 2/3 is one of the factors. So I can put that down here with that. But we're supposed to find all the zeros anyway, so we need to set each of these equal to 0 to do that. So 4x minus 3 equals 0 gives me 4x equals 3, so x is 3/4. Here's 1. And 4x minus 1 equals 0 is 4x equals 1, so x is 1/4 is the other, and of course 2/3 is the third one. Okay, so the zeros are 3/4, 1/4, and 2/3. Negative, no, yeah, positive 2/3. Right. So I got the zeros. The factors are let's see, the factors are 4x minus 3, 4x minus 1, and this weird one, x minus 2/3. I want to talk about that in a minute. All right, x minus 2/3 is a factor, but if you notice, when if I were to multiply all this back out, 4x times 4x is 16x times x is 16x cubed, but originally it was 48x cubed, right? So what's going on there? Well, when you have this x minus 2/3 is a factor. That's not really the original factor. They've just kind of put it that way. They gave us the 0. The factor would be getting rid of this fraction. We could just multiply everything by 3. So if I multiply everything by 3, then that would be 3x. That would just be minus 2. And when I multiply that, of course I get 0. So a better answer for the other factor would be 3x minus 0. So I'm going to erase this. I'll just rewrite it. 4x minus 3, 4x minus 1, and 3x minus 2 are your, and you could set that equal to 0 if you want or not, but these are your three factors. Now, when you multiply 4 times 4 is 16 times 3, you do get that 48, which is what you had originally. All right. And it would happen even if I didn't divide all these by 3. It still would have happened. So since I divided by 3, you can think of this as like, well, I'm adding that 3 back by multiplying this expression by 3. All right, that's it. So that was number what? That was 52. All right. Now these ones with the square roots, let me do 56. So 56. X cubed minus x squared minus 13x minus 3 equals 0. And 2 minus the square root of 5 is a 0. Okay, so let's talk about these square root ones. These square root answers, which are irrational, right? Because square root numbers that won't simplify to whole numbers are in fact irrational. They always occur in pairs, and we call them conjugate pairs. The conjugate of 2x minus 5 is 2x plus 5. I'm sorry, 2 plus square root of 5. I don't know why I said 2x minus 5. It's 2 minus square root of 5, so 2 plus the square root of 5. So I already know just from experience that if 2 minus the square root of 5 is a 0, then 2 plus the square root of 5 is also going to be a 0. And you kind of know that in a way from, the quadratic formula, which has that negative b plus or minus the square root of all this stuff, right? Minus 4ac, which is the part that gives you the square root over 2a. It's a plus and minus, right? So here you got a plus and minus. So in a way, like if that 2 is your b, or your negative b, then what follows is the positive result of the square root and the negative result of the square root. Okay, so, and then there's going to be one more 0, because we know that there's a total of 3 zeros. So let's go ahead and start with the one they gave us, and we'll do division. We're supposed to show that this is a 0 through synthetic division. So I put 2 minus the square root of 5 in the box, and the coefficients are 1, negative 1. I'm going to leave myself a little more room here than normal because of the square root expression. So 1, negative 1, negative 13, and negative 3. All right, bring the 1 down. When I multiply 1 to this, I just get that same thing. So that's 2 minus the square root of 5. Okay, when I add these, the negative 1 gets added to the 2, which is just 1. So that's 1 minus the square root of 5. Now I have to multiply these two together. So I'm going to do that work over here on the side. So that's going to be, let me zoom this out a little bit so you can see better. So I'm going to do 2 minus the square root of 5 times 1 minus the square root of 5. Let's see what we get. So 2 times 1 is 2. 2 times minus square root of 5 is minus 2 square root of 5. Minus square root of 5 times 1 is another square root of 5 minus square root of 5. And that times that is a positive square root of 25, right? So it's a double negative, so it's positive. And square root of 5 times square root of 5 is simply 5. Square root of 25, which is 5. Okay, so now I can add the real parts, or not the real parts, sorry, the rational parts, 5 and 2, which is 7. And combine the irrational parts, which is minus 7 square root of 5. So that goes here. All right. Now when I add these, I just add the rational parts. So what is that going to be? 7, 6, negative 6, I think, right? Sorry, negative 6 minus 7 squared 5. Right. Now I have to multiply this to this. And so let's see what that's going to come out to be. So 2 minus the square root of 5 times negative 6 minus 7 square roots of 5. 2 times negative 6 is negative 12. 2 times that is minus 14 square root of 5. Minus square root of 5 times that is positive 6 square root of 5. And that times that is positive 7 square root of 25, which is times 5. All right. So if you're not following that, pause it and try to work it out yourself and see. But when I multiply square root of 5 and square root of 5, that's what gives me the 5. But I still have that 7, and the double negative makes it positive. All right, so that's 35. So I've got 35 take away 12, which is what, 23? And then I've got this minus 14 and 6, which that's minus 8 square root of 5. Boy, this thing's ugly. Square root of 5. They always are, though. It doesn't look like it's going to work for me, though. So that means, since I'm not getting 0 here, I've made an error somewhere. So I'm going to have to go back through this real quick. So what I'm going to do is I'm going to pause this, find my error, and I'll come back. And for you, it'll be no time at all. Okay, found my error. So when I multiplied, it's just silly adding. I did 2 and 5 is 7. You probably saw it. And then these two, I put minus 7 for some reason. It should be minus 3. All right. So that's at least one error. There might be another. All right, so when I multiply, let's see, I should have put right here, minus 3. Okay, now when I add these, I should have a minus 3 right here. So now when I'm doing all this work, I should have had a minus 3 here. And that's going to change some of these numbers here, right? So this times this is fine. But And when I did this times this, I should have minus 6 here. Right, because 2 times minus 3 is minus 6. And then this times this should be okay. And then this times this, that should be a 3, not a 7. Okay. This is better. So notice minus 6 squared root of 5, positive 6 squared root of 5 cancel out. That's a minus 12. That's a 15. Negative 12 and 15 is 3. That's looking much better, and 0. So we're good. All right. So the resulting equation here is a quadratic, right? So the quadratic is, if I were to write it all out, that would be x squared. That would be the coefficient of x, and that would be your constant. All right, there's no way we can factor that. We don't want to plug that in the quadratic formula. So this trick that if 2 minus the square root of 5 is a 0, that means 2 plus the square root of 5 also has to be 0, which means if I divide this by this, it should go in. So I'm going to divide 2 by 2 plus the square root of 5, and I'm going to use these coefficients, right? So this is a coefficient, this is a coefficient, this is a coefficient of the quadratic factor, okay? So this will be, I'm just bringing these down. So there's 1, this is 1 minus the square root of 5, and this is negative 6 minus 3 square roots of 5. Okay, bring down the 1. So when I multiply 2 plus square root of 5 times 1, I get 2 plus the square root of 5. Notice that the square roots of 5 just cancel out, and you add those and you get 3. Now I need to multiply this by 3, so that just means 3 will get distributed to both of these terms. So that'll be 6, and that'll be plus 3 square roots of 5. And notice these are opposites, so they cancel, and you do get 0 for your remainder, leaving you with this little linear, right? So remember, we started with a cubic. We divided it by something, and then we ended up with a quadratic. We divided the quadratic, now we have a linear. So this is x plus 3. So now I've got all my factors, right? X plus 3 is a factor, so let me x plus 3. And then x minus this. So remember, when you do minus this, you're going to distribute this. So that's going to be minus 2 plus square root of 5. And x minus this one, x minus 2 minus square root of 5. So those are my factors. My zeros are, because of x plus 3, it's negative 3. Because of this, it's going to be, you can just look up here, it's 2 minus square root of 5. And also 2 plus square root of 5. All right, so that's the only way I know that we could have found those, is by knowing this trick here. So let's talk about conjugates for a minute. So irrational conjugates. So an irrational, let's say you have 5 minus the square root of 2. If that's a 0 of a polynomial, then automatically what you do is you leave the first term alone, change the second, the sign, of the second one, of the irrational part, right? So you have a rational part, 5, and an irrational part, square root of 2. Leave the rational part sign as is, so positive, positive. But the irrational part's negative, but here it's going to be positive. So if this is a 0, then so is this. Okay? If they change it around, let's say you see it and it's like square root of 3 minus 6. Well, you might want to just go ahead and put the rational part first. So that would be negative 6 first, and then plus the square root of 3. And if that's a 0 of a polynomial, then the conjugate is going to be negative 6 minus the square root of 3. All right, so now you know what conjugates are, and we use them a lot, not when we get into the next section, which has to do with imaginary numbers and complex numbers. All right, so let's see what else we've got here. So that was number 56. In the next part, it says verify the given factors of the function f, and then B, find the remaining factors of f. C, use your results to write the complete factorization of f. So it's very similar to what we just did. D, list all the real zeros of f. And E, confirm your results by using a graphing utility to graph the function. All right, so starting with 58, we have f of x equals 3x cubed plus 2x squared minus 19x plus 6. And we're given two of the, oh, it keeps going. No, it doesn't. 58. Okay, I'm good. And then we're given x plus 3, x minus 2 are factors. Okay. And we're supposed to verify that these are factors. And then we're supposed to find that there's another factor, right? So there's 3 factors. We've got 2. Well, if we've got 2 factors, we also have 2 zeros, right? So if x minus 3 is a factor, then positive 3 is a 0. And if x plus 2 is a factor, then negative 2 is a 0. Now I can verify that these are factors by simply doing synthetic division again. Another way to verify it would be to plug positive 3 in there and you'll get 0. But since we're dealing with synthetic division, and it doesn't say how to verify their factors, we're just going to stick with synthetic division. All right, so x minus 3 means you're going to divide by 3. You're going to use 3, in your synthetic division, and the numbers are 3, 2, negative 19, and 6. All right, so bring the 3 down. 3 times 3 is 9. Add, you get 11. That's 33. All right, so that doesn't look right, does it? Sure doesn't. So 19, so that would be what? 20 would be 13, so that's like 14? Something like that. Did I write it down correctly? All right, let me pause it again a minute. Apologize. Okay, sorry, I'm making stupid errors today. So you can see that I can feel your pain, right? So that was x plus 3, not x minus 3. I just wrote it down wrong. So that would be a negative 3 that I'm dividing by. So negative 3 times 3 is negative 9. Now when I add that, I get negative 7. Negative 3 times negative 7 is positive 21. All right, when I add those, I get, what, 2? Negative 3 times 2 is negative 6. All right, so I just need to be more careful. All right, so that's confirming that x plus 3 is a factor of this polynomial. All right, but I think it's good. You know, it may be annoying for me to for you to see me making mistakes, but I think it's good for you to see me making mistakes so you can see how you work through these mistakes. And a lot of times it really is mostly just silly errors like that, and it can really be frustrating. All right, now instead of, all right, so I confirmed that x plus 3 was a factor by doing this. Now I need to confirm that x plus 2 is a factor. But I'm not going to divide x plus 2 into this whole thing. I'm going to divide x plus 2 into this, which is also a factor, right? So it's kind of like saying, let me give you an example. Let's say I have 12, and I say confirm 2 and 3 are factors of 12. All right. Well, one way to do that is to say, well, 2 goes into 12 6 times, and 3 goes into 12 4 times. And you're done. But another way to do it is say, well, 12 divided by 2 is 6. And then instead of dividing 3 into 12, just divide 3 into what you got before into 6. And it goes in twice, right? So it's kind of like 12 can be broken down into what? 6 and 2, and this could be broken up into 2 and 3. So now we can see that 3 and 2 are both factors. And if I wanted to show 4 was a factor, I could by saying, well, 2 is a factor twice, so 2 times 2 would be 4. So I don't have to divide both of these factors into the original. I can just go ahead and divide x plus 2 into this quadratic factor. So that'll be a negative 2. And that's going to be 3, negative 7, 2. Now the advantage of doing this is when you're done at the end, you'll have your third factor without having to do any more work. Because by dividing by this first factor, I got a quadratic factor. Now when I divide into the quadratic, I'll end up with my final linear factor. All right, bring the 3 down, that's negative 6. Something's not looking right again. Did I copy that down right? What in the world? I copied them both down wrong. What did I do? So this is supposed to be x minus 2. How strange. So this would be positive 2. So that would be positive 6. Good grief. All right, so now when I add, I get negative 1. And then 2 times negative 1 is negative 2. Add, we get 0. Okay, so now I've got my final factor, right, which is 3x minus 1. So 3x minus 1 is a factor. So is x plus 3. And so is x minus 2. Okay. So let me see. Verify the given factors of the function f. Check. Got that. I did that through synthetic division here and here. All right. B, find the remaining factors of x. Okay, did that. I got that right here, so I'm done with part B. C, use your results to write the complete factorization. Okay, so this is the complete factorization, so I'm done with that. So I could say, well, I guess technically, if I wanted to be picky, I would do 3x minus 1 times x plus 3 times x minus 2. All right, so that would be part C. List all the real zeros of f. Okay, so the zeros, part D, the zeros are 2, -3, and 1/3. And then E, confirm your results by using a graphing utility to graph the function. So the graph, the original, should pass through 2, -3, and 1/3. I'll just go over here to Desmos and do that real quick. So x equals 3x raised to the third plus 2x squared minus 19x plus 6. All right. And then you can see right here, there's -3, there's 1/3, and there's 2. So there's the confirmation. And, you know, for your work to show, you would just require you to do anything super accurate, but you get the basic idea. It goes through -3, 1/3, which is right about there in 2. So it's going to do something like this. Gonna come down. It crosses it at 6 actually, right? So, but I'm not worried about the y-axis, but it does cross the y-axis at 6. Goes through there and then goes down and comes back up and goes through 2. All right. So those are a lot of work, and that's how you do this last set right here. In this last part, graphical analysis, it says use the zero or root feature of a graphing utility to approximate the zeros of the function accurate to 3 decimal places, and B, determine one of the exact zeros. Use synthetic division to verify your result, and then factor the polynomial completely. So let's take a look at that. All right, so looking at problem 66. G of x equals x cubed. Minus 4x squared. Minus 2x plus 8. Please let me have written it down correctly. Okay, so the first thing we're supposed to do is use a graphing utility, and I know that you guys, if you're doing a quiz, you're going to be using one of these, so I'll do that. So we're going to go to y equals and put in x raised to the third minus 4x squared, squared minus 2x plus 8. Graph. All right. So let me read it again. Use the zero or root feature of a graphing utility to approximate the zeros of the function accurate to 3 decimal places and determine one of the exact zeros. All right, so I'm going to see if I can find an exact zero first. It looks to me like right here, this is maybe exact, maybe 1, 2, 3, 4. So one way I could do that is just go to my table, which is second graph, and go to 4 and see if I get a 0 there. And I do. So 4 is an exact 0. So I'll just go ahead and write that down for part B. All right. So now I'm supposed to use, these are not exact zeros. Now going to my table again, I can tell where they are. So like, I know there's one between -1 and 0, right? No, sorry. I know there's one here between -2 and -1 because y switches from positive to negative. So between -2 and -1, there is a 0. And then there's another one between 1 and 2, right? Because it goes from negative to positive. And then, of course, at 4, there's a 0. All right, so looking at my graph, I'm going to go to second trace and do the 0 function. I'll start off trying to find this one on the left, so let me go over there. So that's left bound, enter, right bound, enter, enter. So I recognize that number. That's the square root of 2. That's a negative square root of 2. So that's a negative 1.14 if I go to 3 decimal places. X equals negative 1.414. All right, and then now remember what I told you. That's irrational, right? I recognize that. That's the negative square root of 2. Irrational zeros always occur in pairs. So that means this other one's got to be positive square root of 2, which is going to be positive 1.414. So let's see. 0. Enter. 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 There it is. All right. So I found the one exact 0, which is 4, and I found the two that are not exact. Well, they're not exact yet, right? I've approximated them to 3 decimal places. Okay, so let me read it. So approximate 0 is the function accurate at 3 decimal places, and B, determine when the exact 0 is. Got it. Use synthetic division to verify your result. Then factor the polynomial completely. Okay, so what that means is, since 4 is an exact 0, then x minus 4 is a factor. So I can do synthetic division with 4. So this gives me 1, negative 4, negative 2, 8. Bring the 1 down. 1 times 4 is 4. That's 0. 4 times 0 is 0. Add, you get negative 2. 4 times negative 2 is negative 8. Add, you get 0. All right, so this new factor here is x squared. That's 0x, so I'm going to just leave it out, minus 2. All right, so I confirmed this by doing this and getting a remainder of 0. I found another factor, x squared minus 2. Now this actually will factor to x plus the square root of 2, x minus the square root of 2. You could also set it equal to 0 and solve, and you would get square root of 2 and negative square root of 2, right? So let me show you what I mean. So if I take this and I set it equal to 0, so I add 2 to both sides. Now take the square root. Now when you take the square root of both sides, you got to do a plus or minus. So there's your other 2 zeros, right? So my zeros are 4 square root of 2 and negative square root of 2. Therefore, my factors are x minus 4, x minus the square root of 2, and for this one, x plus the square root of 2. So verify your result and then factor the polynomial completely. Did it. And this is, I guess, technically equal to g of x, right? Because that was the name of the original function, g of x. All right, so that's how you work this set. And this video's gone on longer than I thought it would. We'll have to do a fourth video probably for this. All right. Thank you for hanging in there, and I hope you guys have a great rest of your day. God bless you. Bye-bye.